Hey guys, today's Tuesday, April 28th, and we are continuing on with Goal 7, which is about derivatives, but today we are going to be talking about instantaneous velocity. Just as a quick overview, velocity is basically speed with direction. And as you probably already know from a different math or science class, speed is equal to distance over time. So you can find the velocity by taking the derivative of a position function, which gives you distance, with respect to time. So it gives you over time. It gives you the distance over time. So for example, let's say that S of t represents the distance a person moves with respect to a point where t is the time. If you take the derivative of that function, it gives you the velocity of the person. Note that the units for position will be something like meters, feet, etc. The units for velocity will be the derivative with respect to time, so it could be like feet per second, for example. Next, acceleration is how the velocity changes with respect to time. So we can find this by taking what's called the second derivative of the position function. In other words, we take the first derivative of the velocity function. That will give us the acceleration of the person. We'll talk about what a second derivative is in a minute on an example problem, but the units for this will be something like feet per second squared. Let's do this example together. The distance a particle moves along a path is defined by this function S of t, where t is the time given in seconds and the distance of the particle is given in centimeters. Part A, find the expression for the instantaneous velocity v of t of the particle. So, like we said earlier, v of t, the velocity function, can be found by taking the derivative of a position function. So, in order to find the derivative, we need to know what we learned yesterday. We're going to go term by term. So we'll look at the first term first, 18t. So remember, this is a power function. Technically, it has a power of 1. So you bring down the power, then subtract 1 from the power. Same for the next term. Bring down the power, subtract 1 from the power. Finally, for the last term, negative 1, this is a constant. It doesn't have a variable with it, so the derivative is just 0. Remember, the derivative of any constant is 0. Now we just need to simplify this. So we get 18t to the 0 minus 9t squared. Note you don't need to write the minus 0. And also when you have t to the 0 power, anything to the 0 power is just 1. So we really don't need to write that either. So the velocity function is equal to 18 times 1 minus 9t, because since t to the 0 is 1. So you could skip that step. It's just 18 minus 9t squared. This is our velocity function. Now part B says find the velocity of the particle after 2 seconds. So 2 seconds, this tells us the time, which we know is represented by the variable t. Since we're finding the velocity, we know we need to use this function that we just found in the previous problem. So we're plugging in 2 for time. So we're finding v of 2. That means you basically plug in 2 anytime you see the variable t. So you guys know how to do this. Multiply, do exponents first. 2 squared is 4. 9 times 4 is 36. 18 minus 36 is negative 18. So this tells us that the velocity after 2 seconds is negative 18. Now we need to look at our units. Centimeters per second. Alright, part C says find the expression for the acceleration a of t of the particle. So remember we said a of t is equal to the derivative of the v function, which you can also write as the second derivative of the position function. Since we already know our velocity function, we'll just go ahead and find the derivative of that velocity function. So we're going back to part A again, and we are finding the derivative of this function. So we know that a of t is equal to, now go term by term, the derivative of 18 is 0 since it's a constant. The derivative of 9t squared, we bring down the power, subtract 1 from the power. Now we just need to simplify. So the acceleration with respect to time is equal to negative 18 t to the first power. We don't really need to write the first power, so we can just say acceleration is equal to negative 18t for any time t. Now it says find the acceleration of the particle after 2 seconds. Since we're finding the acceleration, we know we need to use this function that we just found. And since we're finding it after 2 seconds, this represents the time t. So we're basically trying to find a of 2. So what we're going to do is plug in 2 anytime you see the variable t. So 18 times 2 gives us negative 36. And our units on this, since we are talking about acceleration, are going to be centimeters per second squared. Alright, pause the video. I'd like you to try this problem on your own. Here are your answers for this problem. Alright, your homework for tonight is on page 772. You have numbers 17 and 38. You're only doing parts A and B for those. You're skipping part C. And then you're doing number 55 in your book for your reflection question today. Have a good night. Talk to you tomorrow.